Hello everyone and welcome to another episode 5 of the HTTP and C series. If you're still here, thank you so much for watching this far into the series, and to make sure you leave a comment down below giving me some feedback if these episodes are too long, too short, if they should be more topical, more clear, if you need more, I don't know, explanation or less explanation, less yappage, more yappage, let me know. Anyways, last episode we picked a license, which is the AGPL3 license. And I explained some software licenses and stuff like that. Check out that video if you haven't. Today, we're going to actually get into some coding again. So last time, before we created the license, which was 10 minutes ago when I made the other video, I've actually been implementing the responsive status code generation, which I remember. And basically what we did is we just generated responses from strings. And that's, I mean, it's good, right? But it's not enough, because realistically right now, let me run our program. Just running make and then the server. Right now on the default route, we actually serve a 404. And it doesn't necessarily make sense to even serve strings only, because while this is an HTTP server that, doesn't really have a specific purpose, usually you don't want to serve strings only. You want to serve files, right? So what we're going to do today is we're going to implement this as a little file serving web server. The first thing we're going to do for that is make sure I don't have anything that's not committed. Let's pull with rebase, wonderful. And so what I want to do is, also I can delete my notes, I don't need those anymore. First thing I want to do is I want to make a directory called www maybe. And the www directory is going to have all our files in it. So this is going to be our sort of root, okay? And I want to give this to the, well, I want to sort of predefine this, right? So web root char web root is going to be www, right? And I want this web root to be initialized, right? So if it doesn't exist, we want to create it. So the way we can do this is by using the stat. Well, we can figure out if it exists, right? So we can do that by doing a stat on it. And the way that works is, let's make a little function. Well, should we do a little function? I'm not sure. Yeah, let's do the function. Bool file exists, and we're going to take the file name. And so actually, I think we want to take a string view. And to figure out if the file exists, first we make a buffer, right? Because we want to, we'll need a null terminated file name. And we want to hand these around as string views because we're going to get these from the server, right? And the server deals in string views, if you remember. So we want to make a file name buffer. Let's just call it, and we'll just give it a path max or something. Is path max the right one? Let's figure it out. Arch path max. Okay. Path max. Let me see. Let's figure out if that's a thing. Yeah, that's fine. It sounds like that's the right thing. So path max is actually quite a bit. It's a 40. It's 4 kilobytes, right? 4096, and that means that we can still put it on a stack. Though on some systems that might be a little much, but it doesn't matter right now. We then want to set the buffer to 0. Just zero it out to make sure that we don't use any data that's not initialized at any point. Even if we make like slight mistakes, like off by 1 errors and stuff, we still want this to be initialized memory, right? And then we just map copy the into the buffer, the file name, string length, file name, and of course, oh, not string length, file name, sorry. filename.len and filename.start is what they're called. And of course, if filename len is bigger than pathmax, and we return false. Okay. Actually +1. Right, because we need one space for the null terminating byte, right? Okay, perfect. And then the next thing we need is, let me check really quick if I got, no, all good. The next thing we need to do is then to run stat. So stat is this wonderful syscall that, oh my God, here we go. Stat or fstat or allstat or fstatat or something is the wonderful syscall that lets you figure out sort of the size and all sorts of things, metadata about the a file or a directory or something like that. For example, a type of file that it is and things like that. And so we're going to want to use this. So because we're going to use this, let's actually let's see, do we want to do that? Yeah, I think we'll do it like this. So we want to define struct.stat, and of course we need to include stat, which is in sysstat. Pretty easy. And let's see where we are. Here we are. And so now what we can do is we can call stat, which as the first argument, if you look up here, first argument is the file name, second argument is the stat buffer. So what we do is we literally do buff, and then the stat buffer is st. But of course this can fail, so we wrap it in a if stat less than 0, and then we return false. Otherwise, we just return true for now. And we're going to improve this function a little bit, but for now, it's just going to check if the file exists by doing a stat syscall. And there's other ways, right? You could just try to open the file or the directory, but then it becomes a little difficult, right? Because what if it's a directory? Can you open a directory? What about if it's what else do we have? I don't know, a pipe or a symlink. Like what happens, if it's valid or not or whatever. So it's easier to just stat it and see if that fails, because that means that at least it sort of exists, right? Let's call this file system entry exists, because we don't know if it's a directory yet or not. Right, or maybe we'll just do struct stat. It's called fsstat, and we're just gonna return what should we do? Yeah, see, this is where it gets a little difficult, because like I want to sort of give back more information than just this, because doing a whole stats is called just check if the file exists is a little silly, but we will want to know other stuff, like how big the file is, if it's a file directory, stuff like that. So how about we make our own little thing for this? I think that'd be nice. Let's call it fs.h, and let's write a little thing for that. Because I think that's worth, right? That's worth doing. Anything that's worth doing is worth doing twice or something like that. Okay, so fs.h. Oh yeah, we just defined stuff in the header file. That makes sense. And let's see, path max is not defined. Linux limits, string view is not defined. Let's add string ops. And stat is not defined. That's in sysstat. Okay, so let's call this fs stat, and then we have a struct. Get fs, I don't know, Oh, let's call it fs metadata. Yeah, fs metadata, and then we call this fs metadata. File system metadata, right? Or like file metadata or something. And then it's going to return fs metadata with a bool. Can we do a bool? Standard bool, right? And so the first thing is going to be exists, and that's all we need. We'll get to the other stuff later. And then there's a static. Actually, is there? No, it's fine. So it's okay. I had to stop talking for a second there because I was thinking. But essentially, we make the fs metadata at the beginning. We then parse into it. And right now, we don't really put any info into it. And if stat fails, we return it. If the file name is too long, we return it. And then if it exists, at the very end, we set it to true and return the metadata. I think that's fair. And maybe we should call this fs get metadata to sort of keep it in line with the other stuff we did. So now that we have the web root, we can call fs get metadata for the cstr. How do we do that? String view string from cstring. That's the one. God, what a terrible naming scheme I came up with here. Okay, and then this is fs metadata if or web meta, and then of course if the web root meta doesn't exist, we then want to create it. So that's the entire reason we want to do this. I didn't mention that, I think, but the entire reason we want to do this is because we want to make sure the folder exists, right? And we can just call make dir with the path and the mode. So the path is going to be the web root, and the mode is interesting. So I can never remember this. Archman mkdir. So I think it's you basically put a number in there. Oh, that's not very helpful. That is not very helpful. Right. How do you define exactly which ones we want? Mode specifies new mode for the directory cinode 7. Let's look at the inodes are sort of the things on in your file system. Everything is an inode, right? Let's figure this out. Where's the mode? There it is. See discussion of file type and mode. File type and mode, wonderful. So these are the file type ones, and then the mode ones. Come on. File mode component. Oh, wonderful. Right. I guess all we need to do is read write. But I think there's a way to ask mkdir for that, right? Or like to ask, sorry, ls for that. ls can tell us the mode. I don't know how, but it can. No, not dired mode. Interesting. I feel like this can show you But basically, usually they're WXR is what the permissions are, right? So I think WXR is like all permissions, but I might be wrong. I might be wrong completely, but whatever. Let's just try it out. So I think these should be si exec and si write and si read. That should be it, but I don't know. So let's compare. Let's move www to all. And now we have that one, and now let's run like sir. It didn't like that. Undeclared identifier. Yeah, I'm sorry. These are defined inside. What did it say where they're defined? FNCTL? I think they're called F or FC and whatever. That one. Oh, actually, this is a different thing. Also, this needs a pragma once at the beginning. So let's see, pragma. Oh, there we go. I think the reason the other stuff doesn't work is because we are compiling with a. Well, the first thing is, of course, that we need to string ops.h and fs.h as requirements dependencies, if you will. And then the other issue is that we're compiling with C99, which means that technically we need to. So okay, I have to explain this. I think there's this thing called POSIX C-source, and POSIX C-source is something you have to define if you're running with a specific standard. So we're just going to switch to GNU99 instead of C99, and that's going to solve that issue for us. And that's pretty much all. And of course, in the makefile here, I'm using the wrong thing. This should be that one. No input files. Server.c. I might be kind of crazy, but doesn't this mean the first only? Or does it mean all? It does mean all. How do you make a make rule with is it this? No. Make file built in variables. So there is a way to say only this one, I think. Let's see. Foo okay, that's the one with the percent. I think that's the one I meant. Make file syntax is a little funny. No, that's not correct. Oh, yeah, no, I remember now. It's this. Yeah, that works. And of course it says parsing string to parameter of incompatible type string view. And I wanted to fix that last time. I remember this because this was really messing with me. The fact that we have two types, we have a string and we have a string view, and they're the same exact thing. So I'm just gonna get rid of this. And I'm just gonna run a search and replace for string with the word boundary. Actually, I can't do that. No, I can't do that. I can't do that. So I'm gonna run a search and replace for string with string view. So I want to replace this and this, and that and that and that, and not that, and that, and that's it. And then I think I want to move all these down. And are they not called data anymore? They're not called data anymore. Oh, wonderful. Just a little refactoring there. I think that should be good. And this, of course, doesn't compile anymore because we're using string everywhere. And arguably, I mean, we should maybe be calling this string view. Let's rename them. Let's rename them. I don't see why not. String view equal string view from string. Because it bothered me. I think we just built two without really realizing that we had built two. So let's rename those. And right here we can do that all replace as well with the b string b, where \b basically just means border of a word, right? So that you don't go around replacing things that don't need replacing. That one, that one, that one, that one, that one, that one, and not that one, and that's it. And now we should be good, except there's still some problems here. Of course, these are called string view from cstring and string view equal. And there's one more thing, yeah. And again, we have an error. We have a right here string view from cstring, and then fs-get metadata actually accepts a string view. Wonderful. So what's the problem here? This returns a string view, and this takes a string view, passing int to parameter of incompatible type. Interesting. Int is interesting because that most certainly isn't int. Oh, there we go. It was just a problem with the compiler. Okay, not a worry. Not a worry in the world. So this is a lot of work to just create that folder. But we now see that this folder is not created like exactly the right way. So let's check what the mode is supposed to be. Let's see. Just close something. I think, yeah, there we go. I think I need to also add all these. So I think the reasonable way to do this is to say I want these, and then I also want as your where are they? Come on. I seem to not be able to find those. Okay, irgrp, which is group execute, which basically just means the group can executing a directory basically just means entering it. So we want that. We want sir grp. Oh wait, that was that one. Yeah, I want ixgrp, and I want iroth and sxroth. Actually, I don't want roth. I just want xroth. Is that not right? Xoth, sorry. Ix. Jesus. Wonderful. So now let's compare, and now it almost does the right thing. It's missing a read bit for these, which is probably because read group, execute group, read group. Oh, it's the read bit of the others. IR. Okay, so basically we're saying RWX, RX, RX, right, is what we want. So this is, in case you didn't know that, so this is me. Let me just do that differently. And then this is group, and then this is others, right? And yeah, that's how that works, right? So these are the others. So read, don't write, execute, read, don't write, execute, and then this is read, write, execute for me. And I think the resulting number here is going to be, yeah, it's 192, which is 0300. So instead we could just write 0300. But yeah, this is more clear, I think. Even if these names are very annoying, the way this is X for execute and this is exec for execute, you know, cringe. But that's fine. Right, so other than that, these are the same now. So we can now remove that, and we can also create our index.html, which is going to be the first file we actually serve, right? Because that's ultimately why we even do all this. So the index.html should be served when we go to index.html, but also when we go to just slash. They should be equivalent. They should both give us that page. Let's see where we are, 25 minutes. Okay, wonderful. We spent way too much time doing this, but I think this is important to sort of get right. And of course, later we can, change some of these if we want to have different permissions on this particular folder. Right, and so now that we have the index.html, let's actually do a little bit of stuff. So first let's commit the makefile changes. So add dependencies to makefile. Then we commit all of this. So what we actually commit is that we now create a folder, and we also rename replace string with string. Okay, wonderful. And now we add index.html as well. Okay, wonderful. So index.html, I'm just gonna have the AI really quickly write one. There we go. Index.html will be the main file we serve. So this will say hello HTTP in C. And this is gonna be like index. Wonderful. So in order to serve this file, there's a few steps we need to do. The first step is, of course, we need to open the file. We need to, second step, read the file. Third step, close the file. And then fourth step, send all the data in the file to the client. And this is not hard to do, right? These are all sort of basics, but we can actually do quite a few tricks to make this stupid fast if we want to do. So we'll get into that as well. But the first thing is, of course, let's find the place where we want to send that file, and let's get rid of some of this cool code here. So we don't want the hello and bye routes anymore. They were cute, but we don't really need them anymore because we're now going to serve real files. And I'm going to remove this. I'm going to remove this else if statement here. And the first thing is if our route is equal to route, right, which is going to be string view route, string view from C string. In that case, sorry. In that case, we're going to actually send the index.html. So HTTP serve file, client socket, index, string view from C string index HTML. And then what else do we need to know? We need, I think that's it. I think that's all we want. Yeah, I think we want a function that just does that. If I think this should just do the entire thing. I feel like there shouldn't be that much more to do here. So I'll just return -1 if that fails. Okay, so HTTP serve file obviously doesn't exist, so let's build it. HTTP serve file. The first thing is, as we said, the socket. The second thing is a string view of the file name. And the third thing is, that's it. So as I said, the first part is to open the file. And of course, if we go and look at archman of fopen, we see that this is how we open files. We do fopen. There must be a little thing here, right? Maybe not. But basically, you can open a file, you can read from it, and you can write to it exactly like a socket, right? So keep that in mind. You know, the way we use read and write here, I'll read here and write somewhere else. This is the same way that we use files. So the first thing is we figure out if that file exists, right? So we get the metadata. So we need fs metadata file metadata. And we essentially just say fs gets metadata of the file name. Then if file metadata dot exists is false, then we actually want to return HTTP 404 error. Which I think we should probably yeah, let's do HTTP status sendfile, and then if it's 200 we might want to do this differently. Yeah, I think we want to do this differently. I think having this be bool is fine, and then we just make the error 404 static, because I really feel like that's the right move here. Can we not do that? Oh, yeah, of course, initialize element. Let's see. Oh, we could do, we could make this a macro, I guess. Let's do that. String view from cstring str. And so what we're going to do is we're going to just, oh, I can't do that. Can I do that? Not in C89 we can't, but we're in C99, so maybe we can do that. So string view, where essentially we say data is str and len is strlen str. But I don't think that's going to work. So we can actually do size of str, because it's going to be a literal. Let's make this, let's call this differently. Let's call this string view from literal. And this should technically work, because size of will work. And that, well, no, it won't. I don't think it will. String view from literal expands to size of, and size of that. Can I actually macro expand this? And what is this? That should be a pointer, right? Oh, it's 63. That's correct. This is 63, right? Sorry, I'm just making sure that I'm not making any mistakes here. Yeah, it's 63. Okay, wonderful. Okay, string view from literal works, and then we also don't need these anymore, by the way. So we can actually just return the error 404 here properly. And right, serve file. If it doesn't exist, we send that to the client. Generate buff. Oh yeah, right. We have this buffer for the response. Let's have another buffer for the response. I don't really care. It doesn't really matter right now. Wonderful. So we generate that response, we send it, and then we're good. We return false. And then at the very end, of course, we return true, considering everything must have went well if we went there, we got there. So now that the file exists, let's actually do some more stuff in fs-get metadata. I want the file size. And that's important because we do kind of really want to you know, figure out the size of the file without having to read all the entire file. And this makes sense. This will make sense in a bit. Right now, what you would do is you would open the file, you would seek to the end of the file, you would ask, oh, offset am I at, and then you seek back to the beginning, and that way you know how big the file is and stuff like that. But it's not necessarily what we want here, and that will become apparent in a second when we figure out that we can really optimize the way we send files. But for now, let's take st size. st underscore size is the size of the file in bytes, as it says here, and that's wonderful because that's exactly what we want. Okay. And so now what we can do is we can allocate enough memory, right? So first we can, of course, fopen the file, right? So we can say file, file. So we can do file is open, file name. Of course, we need to generate a buffer again. So let's do that. Char file name max path, path max, file name max. And then we mem set, well, we don't really need to, we can just, no, we do, actually we do need to, never mind. We mem set file name buff 0 size of file name buff to sort of clear it out. Then we copy our file name data file, file name buff, file name data, file name size, and the entire sort of it's called len. It's called len. The entire reason why we carry around these string views is because we don't want to rely on null terminated strings when we can avoid it. And this is expensive because we will have to end up mem copying a lot. And we can optimize this out later, but for now it makes sense, right? Because we don't actually ever need to allocate for reading stuff, like for basically passing information around. We just pass around slices, and that way we never have to allocate until we actually get to serve files, and at that point we're allocating anyway, we might as well. But we'll see. It'll make sense in a bit. So file name buff fopen with read binary. And so if file opening didn't succeed, we of course return 404 not found. And we should probably also printf standard error that something went wrong. So couldn't open file s and so the file that we're trying to open is file name buff, and the error is str error now. We've seen this before, so this isn't super new. Did I prefix everything here with error? I did. Let's do that again. Oh, did I not write to standard error before? Never mind. Let's do a printf then. Let's stay within the realms of what we know. Couldn't open file. And then we still return a 404 not found, just in case the file really isn't found or something. Like for whatever reason we couldn't fopen. We don't know why it is, and we just have to assume the file isn't accessible in the way that it should be, so it's not found. Right? Very simple. We don't want to leak any information about what, if the file exists, or if you don't have permissions or something, we're just going to say it's not found. That way, if we're trying to be attacked by someone, then they cannot extract information about which files exist or don't exist by doing this. Well, not easily. They can still probably do a timing attack, but that's a different story. And of course, now we do fclose file. So from now on, we need to go to cleanup if we ever want to exit. From now on, go to cleanup or returning. All right. Okay. And I'm sure we won't need this, but we'll see. And now we want to read the entire file. So we have to allocate a buffer for it. So let's make that, let's say our file buffer is malloc of file metadata dot size and then file buff. we do a little out of memory internal server error type shit. Wonderful. Actually, let's for now ignore this. So to do handle error, and then again we do read, right? So we read the entire file into the file buffer. So we say read file file. What are the arguments to fread? Yeah, pointer to read into, which is file buff, and the size of the data, or sorry, it's 1, and the amount of data, which is going to be file metadata.size, and then the stream, which is file. And so let's walk through this really quick before I continue. So we serve a file, which means every single time we get a request for a file, we do all of this, which is fair. We then open the file, read the entire file, close the file, and then presumably send all that data. What happens if I'm on a system that has, let's say, 200 megabytes of RAM, right? Like a really small server, like a tiny KVM, not associated, by the way, not associated with tiny KVM, but there are, where is it here? There's like tiny KVM hosting. For example, you get like 380 megabytes of RAM. So what if you want to serve a file that's like 10 gigs? Because you have 10 gigs, you might as well serve a file that's 10 gigs. You'll immediately run out of memory, right? There's no memory left on that machine to do that. So you want to probably read a small bit, send a small bit, read a bit more, send a bit more, stuff like that. Because you don't want to run out of this memory. And you can't really ask the OS how much memory do you have, because the OS will always say, I have enough memory. This is a modern optimization called virtual memory, which operating systems, well, kernels do. And they basically say, yeah, I have plenty of space. And even if they don't, they'll still give you more space. You can allocate terabytes and terabytes of RAM as long as you don't use it. You could allocate it on a system that has a few megabytes of RAM. But important detail is that, of course, the kernel knows how much RAM it has, and the kernel also knows about files, and the kernel also knows about sockets. And so the kernel has all the information we actually need in order to send files without having to open them. And that one is called, I'm not actually sure it's called, I think sendfile or some shit. It is called sendfile. So sendfile is a wonderful syscall in Linux, which basically says, take that file and this socket and send the file over this socket. Okay, and so that's what we're going to use, because that is actually really powerful. So instead of using HTTP send response, we're going to sort of copy this, and we're going to not open the file. I'm not even going to bother with actually making all of this happen, right? Because I don't know this is not what we want, so I'm just going to delete it. And so let's make a header, which is going to be the let's make 128 bytes of header, and let's copy the header stuff in there. Actually, we don't need to do that. We can do string view header, and that's gonna be the HTTP response generate is what this is gonna be. Right? I think that's what we want. Let's see if that's what we want. So HTTP response generates it just generates the header, right? Yes, it just generates the header. Wonderful. So we're actually gonna already or actually not here, but let's see. So we do it later. We do it right here. So the header is HTTP response generate with the file metadata size and the HTTP res OK. In the way that this is gonna, we don't need that much buffer space. Like genuinely do not. You probably need more like 64 bytes. The way that this is gonna work is that we generate a header. We then send the header with msgmore. Remember the episode before the last episode or something? And then instead of sending the actual file, we use sendfile to send the file without using any user space memory. And that is the entire fun part here. Because we're skipping user space, meaning we're skipping calling into the kernel and back for every single write and read, we actually get a shitload of performance out of this. And this is what sort of Nginx and other web servers will use in order to serve a file, because this is literally what you want. This is, copy data between one thing and another as fast as you can, please, dear Linux kernel. And the dear Linux kernel really, really likes doing that. It's very good at it, and it can do it much faster than anyone can. Okay. So sendfile means we can run, let's say, the SSL status or result. So result is sendfile. And so we need the outfd, which we have, which is a socket. We need the infd, which we don't know yet. And then we need the offset, which we don't know yet. And the count, which we know because that's file metadata size. So that's pretty much all we need, but hold on. It feels like we must know these two, right? Because the infd is, of course, the file we're trying to send, but how do we get an fd? Well, we can, instead of using fopen, which returns a file pointer, we can use open, which returns an fd. And we can just do that, file name buff, and then open flags. And the open flags are sort of similar to the sort of RB flag that we had before, instead that they are read only. I don't think there's any others. And there's no others, yeah. But yeah, so we just read only, and this is the instead of having the file, we have int fd or in fd. So in fd is the result of open. Now, of course, we do need to technically check, but at this point, we just assume that it worked, and we're going to send we check the result sent file. So we assume this will work because the stat worked, and we will check send file. Actually, no, let's not assume. Let's just say if nfd less than 0, we will return the good old internal server error. Or actually, no, let's return this. Like we said before, let's just return 44 not found. And then, of course, send file, we take the infd. Now we just need to figure out what this thing is. So offset. There it is. If offset is not null, then don't care. Null. Wonderful. And so now we just need to include sendfile. And I mean, you're free to, by the way, if you don't like sendfile or you have another problem that you want solving and not like this, you can obviously just reuse the fread and fwrite syscalls. You could use mmap. You could do all sorts of things. You don't have to use sendfile. I like using sendfile because it's stupid fast and it's exactly what we need right now. But if you have any other idea of what you want to do and it doesn't seem like sendfile is the right thing, don't use it. It's okay. Just opening the file, reading it, and writing it to the socket is not much slower for what we're doing anyways. And so don't worry about that. Yeah, you can always just do that. And of course, we have to close the file again. So we're actually going to have a return code bool result or return value. Let's make that true. Return value false. Go to cleanup. And again, using the good old style of C here, where we just do a bunch of go to because that's much easier than actually cleaning up. Wonderful. Now, if result, and this is mostly the same. 1 second. Right, I don't know what this returns, but I'm assuming it returns the number of bytes. And we need to retry if there's not enough bytes. And of course, we also need to check if it's -1. So if we send less than, actually, let's do a little sst send, because this is going to be important. So sendfile might not actually send all of the bytes, and this is due to restrictions in the kernel and in the amount of memory we have and stuff like that. So we really don't. I mean, it says that like sendfile will transfer at most this many bytes, but it's kind of, I don't know, this, I mean, so this kind of is true, right? What TCP core? Yeah, that's what we're using. Yeah, there's sendfile 64, which is what we want to use. But basically, like, let me go to sendfile 64. Sendfile 64 is basically the same thing. It is literally the same man page. It's just that sendfile 64 doesn't have such a limit. So instead of using sendfile, which has this limit, we're going to use sendfile 64. Now it gets a little funny, right? But it's going to be fun. And of course, sendfile 64. Oops. I think we have to do some sort of macro magic to make this happen, don't we? I thought we had sendfile 64. I might be wrong though. I wonder why sendfile 64 doesn't work. Oh, the sendfile wrapper deals with the differences. Okay, so what we're calling here is actually the right function. And I bet if we look at the source code of it, we would find that it calls sendfile 64. Never mind. So this is the difference between like the sys call and the C library call. So sendfile and the C library, of course, calls the right one. And yeah, so this calls the right one either way. Yeah, I guess I got confused there for a second. But basically, it will only send some amount. It might not send all the data, so you have to call it in a loop until you have everything you want, right? So while the sent bytes is less than the file metadata size, we actually want to send, well, do that. And of course, then suddenly we do want to have the sent bytes here. For the offset of like where do we want to start sending again. Let's see. Data points start reading data, and sendfile returns is variable set to offset of the byte. Yeah, so I think we actually don't want to set it in here. We just want to give it some sort of pointer. So that's going to be of t sendfile offset, and we're just going to zero this out and just give it to the thing, and it'll deal with it itself. Because the way that it works is it basically just tells it will write in there where it stopped, and then you can get it back. and just reuse it here, and it'll use it to figure out where to start again. And of course, send plus equals result until we actually get there. And of course, if result is less than 0, we have run into a problem, and we want to probably do this and get to clean up. Like that. And I think if sendfile fails, we call that an internal server error, and we want to probably log that with printf sendfile error, sendfile failed, for s file name buff error. Wonderful. And then here we want to close. So if in fd is not 0, we want to close in fd, or is not -1. Sorry, it's bigger than 0. No, it's bigger than, it's not -1. Because where is it here? I'm gonna declare it as -1. Okay. So now we will send file in a loop until we have sent the whole thing, and usually this is gonna go on a single call, but sometimes we get to. And then we add the modified send, and once we've sent enough data, we continue, and we're good. SG more, yeah, sounds good. Wonderful. So now this should work if we now call it properly, at least. So we serve the file, and that's it. Let's try that out. Okay, these are different signs. We want to probably fix that by declaring this one size t, because it's never going to be this one, size t. Wonderful. And then, of course, n is unused, so we get rid of it. Wonderful. So now, if we go to the main page, it says 404 not found, but if we go to index, oh, actually, why is that not working? It says request favicon.ico. Okay, didn't seem to work. Of course, we need to prefix the path. That's the one thing I forgot. We need to prefix the path with the web root. That makes sense. So let's actually use web root here. And let's make that a constant. String view web root. And that's going to be string view from literal www. Wonderful. And then in here, we can actually start reading from there, so that way we don't get into trouble. See how we want to do that. Probably give the file name buffer, start it with, yeah, right. So memcopy into file name buff the amount of root, web root, data, web root, len, and then file name buff plus web root len. Actually, let's go to the web root and add a slash at the end. Wonderful. Yeah, this should be fine. It is technically out of bounds here if to do if web root plus file name path max error in return, but we don't care right now. And of course, web root is undefined. Yes, I know. I just did that. Web root. Oh, I can't do that because web root data. Well, in this case, I can do that. This is safe because it's from literal, which is terminated. Yes. Wonderful. That didn't work either. Let's see what didn't work. So it seems like we're not even running. So we say if the URI is equal to the root, which is this, we serve the file index.html. And that seems to be it. Oh, of course. We have to first do this stuff and then get a, this is a little silly, but it's fine. String view from cstring for the file name buff. Because otherwise we don't actually know. Okay, sendfile failed for www, invalid argument. Wonderful. Yeah, I made a mistake. This is off by 1. I want to start right there. And there it is. That's it. We just served index.html. Let's see if that's right. Response. And that's our index.html file. This one right here. We view page source, that's it. And so now, of course, if I put another file, it's not going to serve it yet because we haven't programmed it in yet. But technically we can serve files now. And what's really interesting is that we don't actually use any memory for the file, not user space memory anyways. So we could use strace to figure out what we've been doing here. And we see that we're send filing once and then we close it, or close it, yeah, here. So we're send filing once every time, which is pretty neat. And so now if we make the file really huge, it'll still work. Okay, that's all for today. Thank you very much for watching and hope you enjoyed that. See you next time.